Hello, welcome to Acids and Bases. We're going to do this with videos so that I don't have to do a lecture in the lab, because I just think that gets really long. If I have to do a long lecture and then we have to do a lab, it gets unpleasant. Plus I found this fox hat, which is awesome. So we're going to do a lecture on acids and bases. My kids want to know why I can't do cool lectures about things like Minecraft. But sorry, we're stuck with acids and bases. Okay, let's start with what is an acid. An acid is a substance that produces hydrogen ions, these guys here, hydrogen ions, when dissolved in water. A substance that produces hydrogen ions when dissolved in water. That is an acid. Let's see what a base is. Okay, a base is a substance that produces hydroxide ions, these guys, when dissolved in water. So you have an acid that produces hydrogen ions and a base that produces hydroxide ions. The neutralization reaction. Remember these guys from lab? We did neutralization reactions. When you have an acid and base and you get water and a salt, you participated in a neutralization reaction. Well, we're back to that again. So a neutralization reaction is an acid and a base, and it yields water plus a salt. Acid plus base equals water and salt. Again, we'll do some of these things in lab, but I wanted to get the lecture out of the way. These definitions are limited to reactions that take place in aqueous solutions. So these kind of bases are limited to, this definition is limited to things that you dissolve in water. Well, not everything do you dissolve in water. I want to know if something's an acid or base and it doesn't dissolve in water, or it doesn't react in water, or I don't have water with me. So I need possibly a different definition. But we'll keep going with this for a second. The hydrogen ion, however, is so reactive, it does not actually exist in water. So there are no hydrogen ions floating around in water. Not really. Not for very long. It reacts with water and it gives a hydronium ion, which is actually H3, oxygen, H3O. So when we say hydrogen ion, we're really talking about hydronium, which is incredibly confusing. But just think about them as the same thing. This little this little ion here, see this little hydrogen ion? It's actually right here. Think of it like that. So they're really the same thing. When gaseous hydrochloric acid, HCl, dissolves in water, H3O and chlorine ion are formed. So we have our HCl. It's an acid, if you might remember. We dissolve that puppy in water and we get H3O, which is the hydronium ion, and we get chloride ion there. Okay. This definition, which is Arrhenius's definition, has limits. Like I just said, it has limits because it only accounts for aqueous solutions. You have to have water. And it doesn't really account for the fact that the hydroxide ion, the hydrogen ion, is so reactive it doesn't actually exist in water. So it's perhaps not the best definition. Some things about acids that you should know. They have a sour taste. Don't test me on this. Don't drink hydrochloric acid. Just trust me. Lemon juice, you can have some lemon juice. It has a sour taste. Orange juice, sometimes sour. Grapefruits, sour. Citric acid. Sour milk, bad. Don't drink sour milk. It contains lactic acid, thus the sour taste. Don't drink it because I told you to. Don't do it. I know you want to. Bases are present in many household cleaning agents. So here's your bases: bleach, oven cleaner, ammonia, soap, baking soda, eggs. You can eat eggs. You can eat baking soda if you want. It's gross, but feel free. Okay, so we decided that Arrhenius's definition, not the best. So two Danish guys, Bronsted and Lowry, got together in 1923 and said, I think we can do better. We're better chemists. Let's try. Here's the bummer, though. You have to know the equation, and you don't have this fun system. Arrhenius has this fun system up here that's like 1, 2, 3, 4, 5, 6, and it just gives you these fancy numbers. Bronsted and Lowry is a little bit more complicated. Super fun, people. Super fun. You'll love it. Okay. Bronsted-Lowry acid is any substance that is able to give a hydrogen ion to another molecule. It's all about given and taken here in chemistry. So you got hydrochloric acid. Remember our super fun hydrochloric acid? What does it do? It gives away this hydrogen ion. Sodium hydroxide, what is it? Gives away this little OH. That makes it a base. Acid, base. Okay, let's keep going. Acids are proton donors. Write that down. Acids are proton donors. See? See this super awesome cartoon I found for you? Here, have a proton. Base. Gee, thanks. There's the proton. Acids give away protons. Bases take them. The reaction needs to not occur in water. So it doesn't have to occur in water. And a Bronsted-Lowry acid need not give a hydrogen ion in water. It just gives up its hydrogen ion. Doesn't have to be in water. So you have an acid, you have a base. What do you think is going to happen to this hydrogen right here? Guess. With the base, boom. So the acid gives the hydrogen to the base. That's fairly familiar. I feel like that's all chemistry, just redistributing things. So the base is the receiver, the acid is the giver. Oh, let's go down. Why do I feel like this needs to be up? Let's fix this. Just a second. Hold on. Look at that. Oh, that's better, isn't it? Okay. Different acids can supply different numbers of hydrogen ions. So we're going to name them because it's chemistry. It's all about naming stuff. Who doesn't want to name some acids? This is actually not hard. We're not naming the acids. Just one proton, acids with one proton. I think that's in your notes. I'm trying to follow along in your notes here. Acids with one proton are monoprotic acids. It's not organic chemistry. It's not that hard. So here's some monoprotic acids. Hydrochloric acid, there's one hydrogen that's going to give up here. Nitric acid has one hydrogen that it's going to give up here. These are the monoprotic acids. Anyone want to guess what 2 is called? Boom. Diprotic acids. 3 is triprotic acids. It's not that big of a deal. So H2SO4, H3PO4. Diprotic acids have 2 protons. So here's our sulfuric acid. It's got a hydrogen here to donate and a hydrogen here to donate. Not every hydrogen is available for donation, by the way. So don't think that. It's just sulfuric acid is diprotic. Phosphoric acid is triprotic. It gives away 3 hydrogens. Okay? Mono, di, tri. Moving on. Acidic hydrogen atoms are bonded to electronegative atoms. So this hydrogen is the acidic guy here. These guys, not available for donation. The carbon needs those. You cannot take them. Back off, Jack. This one, this hydrogen is acidic. I'll donate that. If I'm an acid, I'm like, dude, you can take this hydrogen. These 3, don't touch them. These are mine. You can take this guy here. I don't really need him. So acidic hydrogen atoms are bonded to electronegative atoms. So we're probably not going to do a lot of this, but I wanted you to understand because there's confusion very often where, oh, there's 10 hydrogens, so those must be available for donation. No, they've got to be bonded to electronegative atoms. Okay, Bronsted-Lowry base is a substance that accepts the hydrogen from the acid. It's not a terribly complicated definition. It's just so here's the base. Hey, can I get that hydrogen from you? Are you using it? Because I could really use it over here. And there we go. We have this OH comes from the H2O over here. So the acid here, in this case, gave up this hydrogen here and this one here. So this is the acid. This is the base. It accepts the hydrogen. Ammonium will react with water to produce OH ions. So again, this is the OH that came from the H2O. Don't worry if this doesn't make like, oh my gosh, it's so complicated, acids and bases. Relax. We're going to do a bunch of problems in lab. There's not even a lot of problems. It's just really conceptual. And when we get to the end, I'll show you why you need to know. Don't worry, it's actually related to your life. An acid-base reaction is one in which a proton is transferred. Boom. It's all about proton transfer. Here's electrons on a base form with the hydrogen from an acid. Base is going to take that hydrogen, you know what's going to happen, and now the base has the hydrogen and the acid is negative. This base is going to take this hydrogen and now they're together. That's what's going to happen. Base, acid, where's that hydrogen going to go? Just guess. Where's it going to go? It's going to go over here. Look at that. Boom. This is the base. This is the acid. Okay. I will see you in a minute.